Good afternoon, everybody, and welcome to our webinar series, Navigating the Digitalized Industrial Landscape, presented by Phoenix Contact. My name is Gary Huey. I'm with Springfield Electric, and I'm your host. Today's session, Prevent Downtime with Secure Remote Access, continues our discussion regarding the Industrial Internet of Things and enabling remote access to your devices and systems while maintaining a secure connection. In the next hour, we will discuss remote connection considerations, including cellular options and cloud-based software. Just a couple notes. We will have time at the end for a question and answer session. Please type any questions you may have in the chat box as we go. I have muted all attendees for this presentation, and you can unmute during the question and answer session if you would like to talk live at that time. To make you aware, this session is being recorded. If you would prefer to discuss any questions one-on-one, we can offline after this session. So now to introduce the presenter. Today's presenter is David Hoyson. David is the lead product marketing specialist for cellular, IIoT, and cloud technologies at Phoenix Contact. David brings over 7 years of professional experience and is well versed in helping design for the Internet of Things. David, please.
Well, thanks, Gary. First, I'd like to thank Gary and the rest of the Springfield Electric team for putting together this webinar. This is a really good opportunity for us to really provide some education about some of the latest technology trends and applications, so that we can really help solve some of these, problems that industrial companies are faced with every day. So, as Gary said, my name is Dave Hoyson, lead product marketing specialist here at Phoenix Contact. There's my contact information on the slide. Feel free to connect with me on LinkedIn, or if you have any questions after the fact specifically for me, my email address is there as well. And I believe everyone will have access to this presentation, so no need to write it down now. You should be able to find it later on. So without further ado, let's just jump right into it. And I know the title of the presentation was talking about prevent downtime with remote access, but I would like to start off by just polling you, the audience, and ask the question, why is remote connectivity important to you? If you wouldn't mind just typing in the chat box some of the reasons for why you want remote connectivity for your applications. There's no right or wrong answer here. It could be anything from, I'm looking to save on costly service calls. I'm looking to just collect more information from my machines for preventative maintenance. Maybe I want to create new service level agreements and expand my business models. There's a lot of different reasons, but I want to hear from you, the audience. Why is this important? And as you kind of type in the chat box, I'll kind of go ahead and continue along, talk about some of the macro trends that are going on for why I think remote connectivity is important, in the industrial space. And I'd like to just kind of frame this conversation with an image here, showing an example of a group that is gathered in 2005 in Rome, following the death of Pope John Paul II. And you can see everyone's kind of just staring intently. They want to pay their respects. But you can really see there's not too much technology going on. Now, but fast forward a couple of years, very similar event. This was the resignation of Pope Benedict XVI. However, very different image. Pretty much everyone is trying to take pictures. They're probably streaming it live on Facebook. We just live in this society of connectivity. We want instant satisfaction. We want to be able to access the internet whenever we can. We want to be able to stream music and videos. And this level of just need for connectivity it's not unique to the consumer space. It applies to the industrial space. If I can have access to the financial information in my bank account within a couple clicks of a button on my phone, why can I not have the status of my machine through the exact same means? And this is kind of just the continuation of how the industrial space has evolved throughout the years, right? It's the next logical step. We started back in the 1700s with the steam engine. This gave rise to industrial equipment, really. And the industry 2.0 in the 1800s. We had mass production, the assembly line, Henry Ford really kind of grew, started to grow that manufacturing industrial industry. The late 1900s into 3.0, we have automation finally. We have robots and computers and electronics that really took manufacturing and industrial space to the next level. We were able to be more precise, have better quality, higher yields, be more cost effective. However, we're at the next tipping point now. We have all this, all these computers and automated equipment out in the field, and we are now at this point where today we're at Industry 4.0, the industrial Internet of Things, digital transformation. Put your favorite buzzword on it, but this is really now we have all this equipment out there. We want to get data from it. We want to get these machines talking to each other and communicating, sharing information, being networked together. This idea of these cyber physical systems. And Industry 4.0, it's really breaking the mold of what we look at as the traditional automation stack. So in the industrial space, right, we have I/O and sensors really at the bottom, your field bus level. And that connects then to your PLCs, your DCS systems, which connect to your SCADA systems, which connect to your manufacturing systems, connect to your enterprise resource planning systems. And then finally, there's probably a layer of cloud. Maybe IT is deploying endpoint protection on some of the devices and managing it via the cloud, or they have servers that they're running some of their enterprise software on. But the way that traditional automation works is each of these layers, they can really only communicate one layer up or one layer down. Traditionally, your I/O and sensors are not talking to your ERP system. They're not necessarily talking to the cloud. And this whole idea of Industry 4.0, IIoT, digital transformation, it's really trying to just flatten this model and have everything be interconnected with each other. You're having the machines on the plant floor talking to the ERP system, talking to the cloud, talking to the HMIs. And this is, a great case study that everyone's familiar with, that is kind of the front runner of this is Amazon, right? Everyone knows Amazon. And Amazon, they have their entire operation connected from the time that you put a purchase order for coffee on their website. That order is sent to the factory. There's a robot that has that coffee stored on it. If it's a high-selling item, that robot knows to be at the front of the line. If it's a slower one, maybe it's in back, but it's going to drive its way up. It's going to, get to the assembly line. Someone's going to pick it. It's going to get a label on it, shipped out the door. You're going to get a picture of that box taken and emailed to you when it's delivered. And within a day, you've just had coffee delivered, all thanks to IIoT, the interconnectivity of all of these systems. And this whole idea of internet connectivity, it's really industry agnostic. It's happening everywhere. There are some big front runners that have adopted, the early adopters who have really taken to it quickly and early, but we're seeing it everywhere else too. We're seeing it in water treatment, we're seeing it in oil and gas, we're seeing it in manufacturing, agriculture, offshore production. Regardless of what the industry you're talking about, we're really seeing this trend where people want connectivity. They want to be able to interact with their devices, their assets, and they just want this machine-to-machine remote connectivity. And so with that, I'd like to then, let's take a step deeper and look at what are some of the actual real applications and what are the technologies that are really enabling some of this connectivity and the remote connectivity of it. And typically, when you think of remote connectivity, you're thinking of remote assets, right? Something in the middle of nowhere, Texas, that's, nothing's really by it. But let's actually first start inside the factory. And I'm going to refer to this remote connectivity in the factory as just any of these devices being able to communicate with each other wirelessly. Sure, you can have copper and fiber runs throughout the factory, but when you have wireless technology, you enable mobility, redundancy. You have all of these automated guided vehicles driving around the warehouse. You have the automated storage and retrieval systems that help store and find all of your different products. You're going to have information communicating from these devices up to the offices, up to the IT department. You're going to have some of these, the the lines, the assembly lines being talking to other ones. There's a lot of this different communication that is going on, and we need a secure and reliable way to enable all of this communication between these devices. And so the first kind of technology I'd like to highlight is wireless LAN, WLAN, Wi-Fi. And most commonly now, a lot of people are adopting this idea of wireless mesh, which is a really nice technology for self-organizing network structures. So you can have these mobile robots moving about the warehouse or the factory, communicating each other over a wireless network. You can have built-in redundancy. You don't even need access to the internet. You don't need infrastructure. All of these devices can communicate on the same network with each other so that you can really improve the efficiency of your operation. And at Phoenix Contact, our flagship product that we offer that can really enable this, this wireless mesh capability is our FLWLAN 2101. We have kind of a wide portfolio of WLAN products, but this is really the standout one for that wireless mesh. Now, when we talk about this wireless factory communication, there is another technology that is making a lot of headlines, and that is 5G. So regardless of what T-Mobile or AT&T or Verizon show you on their TV ads, 5G is not necessarily being developed for the consumer. Yes, some consumers will eventually get to take advantage of it, but the true use case of 5G, when you really want that 10 gigabits per second data rates, when you want that less than a millisecond latency, when you have hundreds of thousands of devices all communicating to each other, 5G private networks make a really great technology to enable this application. And so we're seeing that private networks inside of factories and warehouses are starting to look at 5G private networks as kind of an alternative to Wi-Fi. Because you get the higher data rates, you get more traffic on the network, you can enable more of this machine-to-machine remote connectivity. With the bigger data rates, maybe you have some artificial intelligence or machine learning applications on the machines that can then, while they're talking to each other locally. So 5G is going to be a really cool enabling technology for these this factory automation. And if you've been following any of the press releases that Phoenix Contact puts out, we have actually developed a 5G router through a partnership with companies called Ericsson and Quectel. And it's really just a research project at this point. It's not a fully released product, but 5G is still in its infancy. It's not really fully released either yet. So we're developing this to kind of learn what are some of the applications, what are some of the limitations, and then so that we're in the future, once 5G has become more commercially available, we're ahead of the game and we have a product available to release. So with that, let's take a step outside the factory now, and let's talk about maybe some of these more remote industries or applications. And again, like I was saying, remote connectivity applies to all of these industries, right? It's not specific to process. It's not specific to electric power. It's not specific to marine. There's all these different industries and applications where you're going to have assets out in the field, and you're going to want to interact with them at some point in some way. And there's a variety of different applications and use cases for this, kind of longer distance remote connectivity. The first of which, and maybe the most simple, is just some basic remote alarming and control. So in this example, there's some generic looking water pumps out in the field. And if there's ever some kind of event, something goes wrong, maybe you just want a text message or an email to be sent out to a group of regional technicians so that one of them, whoever's closest, can go troubleshoot the issue. Conversely, maybe if it's something really simple, as I just want to open a valve or turn on a pump, maybe I can just send a text message to that device. I can actually turn on the output of the PLC and kind of resume operations and fix the problem instantaneously just with a text message. I don't even have to travel to the site. So this has become a very, very common and popular use case for remote connectivity. And at Phoenix Contact, we kind of have a whole portfolio of products that can satisfy and meet some of these needs. Our FLM Guard has, it's our tried and true security router that's been around for a lot of years now. And one of the nice features about it is it does have 3 inputs on it that can be used to send email. So if you want to just get a daily status report, or if you want to get notified of an issue, this product can send an email to a number of recipients and let them know the status of the operation. Now, we also have cellular variants that they all support email as well, but because they're cellular, you get to take advantage of that text messaging. So text messaging is something typically proprietary to the cellular products. The network operators, the SIM cards, they all enable that communication. So we have some native features built into our products where if an event goes wrong, if you just want to trigger an output, whatever it is, you can do that all through texting or an SMS. So we have a entry-level product called our TC router, and then we also have the FLM Guards, which are essentially just the cellular variants of the FLM Guard. The next application that I'd like to talk about is this idea of machine-to-machine remote connectivity. So this is typically, you have assets out in the field, they're all producing, consuming data, and you want to be able to monitor all of these assets for supervisory control and data acquisition. This is your common SCADA type application. So you probably need some type of VPN tunnel to connect all your remote devices back to a central server so that you can kind of monitor them. You can keep track of the status. If an issue occurs, you can control the outputs, or you can modify settings. And we have a couple of different technologies that really enable this SCADA type example here. The first of which is the license-free radio. In the United States, we leverage the 900 megahertz part of the spectrum for this. And we have a product called Radio Line that does just that. It can communicate over 900 megahertz, serial data, analog, digital I/O. It's really simple to use, plug and play. We have a outdoor ready box that can withstand all the harshest weather environments you can put it in. But these types of products, they give you that long distance remote communication for just sending that serial I/O data. So you get up to about 20 miles, all leveraging license-free 900 megahertz. But these products can have some issues, right? In order to get that full 20 miles, you need line of sight between all of your remote sites. If, say, the trees start growing too tall and they get in the way, you might have some connectivity issues. So we've seen that just using industrial routers and cellular radios are another alternative to 900 megahertz. Yes, you do have to pay for data plans at this point. It is not license free. It's licensed radio spectrum at this point. But thanks to the consumer demand for having connectivity with my smartphone all over the country, there's cellular base stations everywhere. And cellular has become a very robust and reliable technology for connecting all of these remote assets to your SCADA systems. So again, there's many different ways to build a network for a SCADA application, right? So you might want to have one of our FL or factory line M guards at the SCADA center, but then all your remote sites, you have maybe a cellular radio out there as well to communicate back. And again, we have a couple different options between the TC router and the TC Guard. They're all depending on what the needs of the application are. Do you need advanced security features? Do you need redundancy in the network? Is it just a simple point-to-point VPN? Do you have different types of I/O points that you need? We can really think about, what is the right product for the application. There's many ways to build a network, but it really comes down to, what are the needs of the application? So then these SCADA systems, that was kind of the industry 3.0 way of doing things, right? A lot of people are now moving to the cloud for sending some of the sensor and process data for monitoring and analytics. The cloud is becoming widely adopted by IT departments everywhere. It's being a little slower adopted in the OT space for the industrial segment, but we're seeing the trend that is becoming more widely adopted because of that interconnectivity to the different systems, because of all of the different services that are available. For example, if you go onto Amazon Web Services website, they have probably a couple hundred native services that they offer alone. And then you look at the third parties out there, it just goes up exponentially for the number of things you can do in terms of security and databasing and storage and visualizations and analytics and machine learning. Your options are endless once you're on the cloud. And to get to the cloud, the most common way of doing things today is since we have legacy equipment out there, right, in the industrial space, we typically have assets out in the field for 15, 20, 30 years. And a lot of these industrial systems, they're running industrial protocols. That's how they communicate to each other, right? So think about Ethernet IP or Modbus. And so what we do is we take an edge controller or a gateway and we just add it to the network. So we're not going to replace the PLC that's out there. Keep the Allen Bradley PLC, keep the Siemens PLC, whatever it is, and then just add a edge gateway to it so that you can collect some of that data. You can maybe do some computing conversion, but ultimately you're going to take whatever that industrial protocol is, convert it to a lightweight IoT protocol, the most common of which is MQTT today, which is extremely secure. They can wrap it around TLS for encryption and send that data up to the cloud where it can then be stored and visualized. So in terms of the edge controllers and gateways at Phoenix Contact, we have a nice little tiny IPC called our BPC 1500, or we have our PLC Next controllers, which PLC Next is a full-blown PLC. However, it's also a Linux box. So if you wanted to run and install your own application on it, you can do just that. But then when you get to the cloud, we have a service called our Profi Cloud, which is really easy to use for just some basic data storage and visualization. However, you're not limited to that. If you're already running something on AWS or Azure, you're more than welcome to install AWS Greengrass onto that BPC and get your data connected to Amazon services as well. So there's a lot of different, ways you can get to the cloud. And once you're there, a lot of different things you can do as well. And then finally, the last real main use case that I wanted to talk about is this idea of technician to machine remote access. So this is securely connecting a technician to a machine over the internet. And this is typically done with a on-demand VPN connection. So this is not a always-on VPN connection like you might see in a SCADA application where you need 24/7 connectivity from the remote assets to the SCADA server. This is more of, say you're an OEM and you get a call saying your machine is acting up. You want to be able to just remotely and securely log into that machine to make some changes to the program. Maybe there was a common vulnerability that was released for one of your network devices and you want to update the firmware to patch it. Either way, you're just trying to log into that network, make your updates, and then get out. And so to enable this connectivity, we at Phoenix Contact have a service that we offer completely for free, as long as you have our hardware, called our FLM Guard Secure Cloud, to really try to simplify this connectivity. So VPNs are not exactly easy to set up. They can be difficult to maintain, and we try to simplify all that complexity through our FLM Guard Secure Cloud service, which then will enable applications like being able to remotely and securely log into an IP camera to check to see what's going on at your facility. Or as I mentioned, maybe you have to update PLC settings to make a program change. Regardless of what you're trying to do, you, a technician, want to connect your laptop to that IP device securely over the internet. And again, we're a hardware company. We have a lot of different hardware options to enable this connectivity through our FLM Guard Secure Cloud. If that's the only thing you need is that connectivity through the Secure Cloud, we have a real entry-level product called our TC Cloud Client. It is really good at just that basic level remote connectivity. Now, if you have other needs or applications, so maybe you do want to connect it to your SCADA server, or you want to be able to send out those emails or text messages or whatever it might be, we also have the FL and TC FLM Guards as well. They all support the FLM Guard Secure Cloud natively. It's really just a simple configuration that you download from the internet and install onto the device. And let's say you don't want to install one of these pieces of hardware on every piece of equipment. We also have a couple of shippable offerings that take the Cloud Client or the TC FLM Guard, the cellular products. They package them inside of a robust and durable Pelican case so that they can just be drop shipped anywhere in the country. You get a call that something's going wrong, overnight one of these Pelican cases to your site, have someone on site plug it in and power it up, and you have instant remote connectivity to your equipment. So finally, you can't talk about remote connectivity without talking about cybersecurity, right? We have all of these different assets now being connected to the internet. Cybersecurity needs to be thought of at the beginning of a project rather than an afterthought. There's been some really big, examples in the past. 2015, Ukraine's power grid got, a third of it got shut down. 2017, the shipping giant Maersk had their entire shipping operation just hacked with ransomware, costing them $300 million or more in losses. And so when you have these devices connected, you really got to think about cybersecurity, and you have to think about it holistically. And you have to practice kind of a defense in depth model, right? So you're going to have different layers of your network, and you have to have different layers of security at each of those layers, right? So you have physical security, device security, your control network security, IT security, policies, procedures. There's a lot of different ways that you can build really strong security principles into your networks. First of which is that physical security. And this is something that's pretty simple, is just make sure the cabinet's locked or block unused ports so nobody on site can tamper with it. Something real basic, but it actually can go a long way in providing that on-site protection. Changing default passwords and using strong passwords. I'm sure a lot of IT departments at your offices, at your companies, they have you change your Windows password probably every 3 to 6 months. And that's really good practice, just to keep all these adversaries guessing and make it difficult for them. And a lot of them have password rules now. It's hard to create an account on any website without needing 8 characters, upper lowercase, special characters, numbers. And this is all for good reason. It becomes exponentially more difficult to hack a password with the more protection and strength that you build behind it. There's some products that are very specific for networking security. So there's things like managed switches and WLAN radios and security routers that can employ features like strong encryption, port access management, so like blocking unused ports, employing like least privilege firewall rules so that only a specific device can communicate to another specific device, and then all other traffic is dropped or blocked. And then finally, using VPNs to securely communicate over the internet to your devices. VPNs are they're authenticated, they're encrypted, and it's a very good way to ensure that secure remote connectivity. Segmenting your networks is another great way to make sure that if something does occur within one part of the network, it doesn't spread to the rest of the system. And so you can see here we have pictures of our M-Guard, which is really a good firewall router where you can actually segment each of your machines. You can segment the service network. You have firewalls on your company network and the internet, and really just try to separate everything and employ least privilege firewall rules, again, to limit traffic so that a machine doesn't accidentally start talking to something because an adversary got control of it remotely. As I mentioned, VPNs, really great way to secure and encrypt all your traffic. As I mentioned, our M-Guard Secure Cloud is a service that we offer for free to kind of help with simple VPN deployments. However, this VPNs are not proprietary. Anybody can create a pair of certificates and create VPNs themselves. And it's a really good practice if you have remote devices that are separated and you want to be able to access them to use VPNs to really secure down that traffic. And then finally, I talked about it a little bit earlier with when I mentioned 5G, but using private cellular networks is a really good best practice for securing a cellular network. The network operators, Verizon and AT&T, they've put a lot of investment into this recently, and they make it pretty easy to set these up. So what this is you get your own dedicated cellular network. You have specific SIM cards that can only talk to other devices on the network. They'll come to your offices, they'll install big routers to enable all of the routing and networking rules, but it makes sure that your traffic never sees the public network. So this is a really good way to make sure that unauthorized users cannot access your information. And then, so finally, I would like to just kind of wrap this all together with a couple of customer examples. So first of which, we had a natural gas company that they wanted to connect about 250 natural gas pipeline RTUs to their SCADA network and have the ability for technicians to have remote access for troubleshooting. And because they're a natural gas company, they were required to meet the NERC CIP security compliance. So NERC is North American Electric Reliability Corporation. They can actually fine companies if they don't practice the best cybersecurity principles. And this can be very costly fines. So they needed to kind of update the security of all their systems and enable some of that secure remote access. And so in order to help them out with this, we deployed our Cellular M Guard, the TC-M Guard 4G at all of the remote sites. And then we also used our 19-inch rack mount FL Centerport M Guard devices at the server sites. We had 2 of them there, so we had redundant VPNs to all the sites, so that if any of the communication ever broke or failed on one of the sites, the other one was still up and running, and they would always have communication. And then we also had our MGuard Secure Cloud, so the technicians were able to log in and remotely access their sites. So this greatly improved the security of the network, and it provided that remote connectivity and on-demand access for technicians. Another example was a wastewater system integrator. They needed advanced remote connectivity to a lead lag application for well pumps. And to accomplish this, they use our TC router 4G LTE cellular modem. And they used this modem for just basic internet connectivity so that they can push data out of the network up to their cloud platform so that they could monitor the system, and they could, for diagnostic purposes as well, for kind of preventative maintenance, look for trends over time. But that was just really outbound traffic. They had other inbound traffic blocked for security principles, but they did have a VPN tunnel that they could connect on demand to this RTU for troubleshooting and updates. And then on top of that, they used the text messaging features of the TC router. So they had some digital inputs. They could send text messages to local operators in the event of an error or fault. But then the operators could also send a text message back to the TC router, turn on an output, which would turn on and off the pump remotely. So they really had full control. This was really a really cool, full, all-encompassing remote connectivity example here. And then finally, the last application I'd like to talk about is this idea of, we had an OEM who needed a premium IoT offering. They had this corporate mandate from their executive team that said, we need to differentiate our machine in the marketplace, and we think the way to do this is through IoT. The corporate management team, they didn't really know what that meant, but that's what they wanted their, the managers and the control engineers to figure out. And so we helped work with them to come up with a solution and figure out what do they really need. And it turned out they wanted local access for on-site technicians. And to do so, we used our FLWLAN product to give local Wi-Fi connectivity so that an on-site technician with an iPad could bring up the HMI of the system and check on some diagnostic information of it. They wanted remote access for the OEM to have maintenance and support so that the OEM didn't have to make costly service calls to go troubleshoot their machine, or for the first couple months when it's deployed to optimize the performance of it. So to do so, we used one of our FLM Guard products and our MGuard Secure Cloud remote access service to provide that remote connectivity. And then finally, they wanted cloud-based data services for just to kind of monitor how the machine would perform, look for trends over time for that preventative maintenance idea. And to enable this, we're using our Cloud IoT Gateway product, which is pretty much just that protocol converter where it takes in the industrial Modbus data and it converts it to MQTT to send to the cloud. And they're using our Profi Cloud service, which I had mentioned earlier was a really simple and easy to use cloud-based data storage and visualization tool. So with that, that's all I had for my presentation. I thank everyone for attending, and I would like to turn it back to Gary to moderate questions.
Thank you, David. Appreciate that. Great information. So now we're going to go to a live Q&A session, question and answer session. I did put my contact information in the chat for everyone to have. So let's, we do have some questions here in the chat. Let's start with this one, David. Will 4G become, and this is from Brandon, will 4G become obsolete once 5G is really established?
So that's actually a great question, something I get pretty often. And before I get to the answer of it, I'd like to just backpedal a second and talk about just cellular overall. Whenever they came out with 3G, it was really just a way to enable people to send pictures to each other through their cell phones. You know, think about the old Motorola Razr flip phones. And as the cellular technology started to evolve, the real use cases and customer demand started to come about. So when 4G came about, all of a sudden we had this massive demand to be able to stream Netflix and to work remotely and just have this high-speed connectivity. And as a result, the network operators, they spent the past 10 years building 4G base stations all over the country so that more or less you could drive from New York to California and stream Spotify and have access to Google Maps while you're driving. And so that 4G technology, it's deployed and it accomplishes a lot. It is very good technology and it's not really going anywhere. The 4G and 5G are actually going to work kind of in conjunction with each other. So the way it's going to work is some of these factories, when they deploy a private 5G network, they're actually going to use the 4G network to go back to, say, Verizon or AT&T to authenticate devices and authenticate the network subscription. Because the 4G radio waves, they tend to operate in the lower to mid band of the spectrum, which goes further distances. Whereas the 5G typically is going to operate in the higher parts of the spectrum for those faster speeds and small bits of latency. So what's going to happen is you're going to see little 5G private networks popping up, and then you're going to see 4G still covering the rest of the United States to really provide that like long distance connectivity. So.
Okay, thank you. Brandon, remember everyone is muted, so you have to unmute yourself. But Brandon, did that answer your question?
Yeah, definitely. Thank you, David.
Sure.
Okay, next question came in from Paul. It says, if we have PLCs with the same IP address and changing it is not an option, how could we solve this? And Paul, I will unmute you, or you can unmute yourself if you need to elaborate more on that question, or David, if you need more detail to that.
No, this is a very common use case that we see all the time, and the answer to it is network address translation. We have machine builders, say for an example, that they put the same network on every machine. They all have the same IP addresses, and then we kind of put one of our FLM Guard security routers on the edge of that network, and then we can establish a NAT role so with using virtual IPs. So that you can keep the machine having all the same IP addresses, but then whenever you set up that VPN tunnel to it, you can use a kind of a virtual IP or a kind of a fake IP that will connect that VPN, but then the traffic will get natted to what the real IP address is. So this is a very common use case. We have a whole team of technical engineers at Phoenix Contact that can really help, set that up and make sure that the configurations are done properly. But this is something that is it's not unique. It's not the first time we've seen it. It's actually pretty easy to overcome.
Paul, did that answer your question?
Yep, that's okay. I mean, you need an NAT router per PLC.
It depends on how your network is set up. If yes, they're all kind of connected locally, you can't have the same IP address. Otherwise, you're going to run into conflicts. But you could
Exactly.
if you have a NAT router there or a NAT switch there, you could do some local NATing.
But per PLC, I mean, one NAT router for each PLC.
That'd be a good way to segment your network. Yes.
Yeah, because it's really expensive. That's what I have.
Yeah, and like I said, we also have NAT switches too that can kind of do some local natting as well too.
Yeah, okay. That NET router is the answer. Thank you.
Thank you, Paul. We have another question which came in from Joe. How can I prevent anyone from viewing the data I put on ProfiCloud?
Yeah, so with the cloud, the same defense and depth security principles are employed. So some of that is just basic user and access management, right? Or identity and access management. So when you create your own ProfiCloud account, that is your own separate account. Somebody would have to get your credentials in order to log into it. The database is secure, it's all encrypted. So if somebody does find, get access to the server where ProfiCloud resides on, they're not gonna be able to access it. Only you who are authenticated are able to access that data.
Okay, thank you. Did that answer your question, Joe?
It did. Thank you, David. Is that with just Windows authentication, or is there a secondary?
No, so we actually, you create an account through the ProfiCloud. So that's something that we kind of manage and maintain. We're responsible for that security of it. But you'll create your own organizational account, and you'll have your own unique username and password. And every member of your organization will have their own unique username and password that they log into. But then you're all kind of part of that same organization. So there's some multi-tenancy built into it, if you will.
Okay, are you good, Joe?
I am, thanks.
Sure.
Thank you for submitting the question. We did have another one come in. This one's from Robbie. With the MGuard Secure Cloud being a free service, what are the limitations?
Great question. So as I mentioned during the presentation, we're really a hardware company. We really want to sell our hardware. So we offer the MGuard Secure Cloud as a 100% free service. There is really not too many limitations. There's no technician limit, there's no device limit. The only limitation of a secure cloud is it's a VPN service. So you can't stream data to it. You can't do the data services. We have ProfiCloud for that specific use case. But for a simple just VPN connectivity, the MGuard Secure Cloud is great. I know some of the competitive products out there, they like to be a freemium service where maybe they'll give you a taste and they'll limit bandwidth, they'll limit technicians, for the free offering, but then they charge you more if you want some of those features. We don't do any of that. So you can add as many people as you want, as many devices you want, and we're not going to, upcharge you or, try to nickel and dime you over that. We're here to try to sell the hardware to connect to it.
Okay. Robbie, did that answer your question? You're still muted.
We lost Robbie.
We may have lost him. It looks like he dropped off. Are there any other questions that anyone has live? That wrapped up what we had in the chat box. Is there any live questions that anyone has?
Hi, David. This is Electric. Sorry, I got in here a little bit late, so you may have covered this. But for the cellular devices, what does it take to get a cellular plan set up, and what are the costs associated with that?
Yeah, that's a great question. So I know we at Phoenix Contact do not sell data plans. We just sell the hardware. But there are a few different options to get data plans. And honestly, I highly recommend checking out some of the online resources that Verizon and AT&T have created over the past couple of years. So Verizon has a website called their ThingSpace. So think Internet of Things. So it's the thingspace.verizon.com. And you can go on there. You can buy SIM cards and data plans directly from the internet. You don't need to call anybody. You don't need to, be on hold with Verizon, getting lost in an endless sea of support people. You can do it all from the internet. And I've done it. The SIM cards arrive in 2 to 5 business days, depending on shipping and whatever. And it's pretty easy. The average cost of a data plan And it really depends on number of devices, kind of features, things like that. You could probably expect to pay something around like $15 per month per device. But as you go up in devices, you go up in data, the data becomes cheaper. So if you say you have 100 devices out in the field, that cost per device is going to go down pretty significantly. AT&T has their own online marketplace as well. It's called, I think, marketplace.att.com. You can do the exact same thing. On both these websites, you can actually search for our products. You'll find them on there if you just type in Phoenix Contact, and it'll kind of make sure that you get the right SIM card. Whereas if you call just one of the support people, even though our devices are all certified and registered with AT&T and Verizon, sometimes the support person, they're only familiar with supporting cell phones and tablets. They're not exactly familiar with supporting industrial routers. So that's why I really like the online way of getting things. There's also some MVNOs, mobile virtual network operators, that sell SIM cards. So you can kind of go through some of those resources as well. If you just kind of search MVNO, I'm sure you'll find, 10 pages of Google search results. It'll show you, who are out there. But you just have to make sure that you buy the right SIM card for the right kind of device. So our device is a LTE category 4, which we find is kind of optimized for the industrial space. It's low on power, but it also gives you up to 150 megabits per second for download speeds for sending PLC data, some of that remote communication. And you have to make sure that you get a Cat 1 or above SIM card for our device. There is some other types of data plans out there, like they call them LTE Cat M or NB-IoT. Those use different SIM cards. So you just have to make sure that you buy the right SIM card. And as I mentioned, if you do the online way, as I talked about, that guarantees you're going to get the right SIM card for our device. Does that answer your question?
Yeah, great info. Thanks, David.
Sure thing.
Okay, thanks, Kevin. Do we have any other questions? Any more questions? Okay, well, hearing none, we're going to go ahead and close out. Springfield Electric, in partnership with Phoenix Contact, can assist you in these solutions, including the specification, design, and implementation. In closing, we appreciate you joining us this afternoon. We will be sending a follow-up email with information about what you saw today and a short survey. Your feedback is very important to us. As you see on the screen, next week, Thursday, October 15th, at 1 p.m. Central Time, we will host our third session in this webinar series, Life on the Edge, Your Gateway to the Digital World. Please register for and join us next week. I'll see you there. Goodbye, everyone.